So let's discuss the exercise 3. We have our total cost function, which is equal to 2q squared minus q plus 8, and our task is to find the equations of different cost functions from this. So our variable cost, it is the part of the equation where we have our q. So this part will be our variable cost, 2q squared minus q, and our fixed cost will be a constant which we have in our function, and in our case this is fixed cost, just a constant. So how do we find average variable cost? We need to divide variable cost by q. So we take our variable cost, 2q squared minus q, divided by q, and receive 2q minus 1. How do we find average fixed cost? So we take our fixed cost, which is equal to 8 divided by q. Speaking about average cost, we can obtain it from using two methods. Firstly, we can divide our total cost by q. So let's take our total cost function. It will be 2q squared minus q plus 8 divided by q, and we will receive 2q minus 1 plus 8 divided by q. And the second option is to use the formula average cost is equal to average fixed cost plus average variable cost. So our average variable cost is equal to 2q minus 1, and our average fixed cost is equal to 8 divided by q. So we receive the same answers. And finally, let's find marginal cost. It is the derivative of the total cost by q, and firstly we need to write the constant here, take this power down 2, and the power here will be 2 minus 1, just 1, and the derivative from q will be equal to minus 1, and the derivative from 8 will be 0, so we will not write it. So our marginal cost is equal to 4q minus 1. Let's consider the next exercise, which is about short-run total cost, points of shutdown, and so on. So we are given our short-run total cost equation. It is equal to 100 plus 20q plus q squared. And you know from the previous exercise that this part, which contains only q's, it is variable cost. So our question is how much will be quantity supplied in the case where marginal cost is equal to average variable cost and in the part B, where our average variable cost is at its minimum. So in general, the graph of the costs in case of short run, we will see that our supply curve starts from 0, goes to this point, because here we have minimum of our average variable cost, and then our supply curve continues along the line of marginal cost, and our point of shutdown is here. This means if we go below the minimum of average variable cost, we will not produce. So if our price in the market is below average variable cost, we will not, below the minimum of average variable cost, we will not produce and will shut down. So in the part A, let's find the equation of marginal cost. And marginal cost, in our case, we will need to take the derivative from our total cost function, and it will be equal to 20 plus 2q, and the equation of average variable cost will be our variable cost divided by q, which is equal to 20 plus q. And if we draw a graph, we will see that our marginal cost and our average variable cost have an intersection in the point 20. So as you remember from the previous picture, our supply curve will start from 0, goes to the price 1, where we have minimum of our average variable cost, and in our case this point 20 as the minimum of average variable cost, and then our supply curve will continue along the line with the marginal cost. So we can see that this point is the point of shutdown, meaning that if our price goes less than 20, we will not produce, or yes, and we include this point. So if our price is equal to 20, we will not produce anything. So, and in mathematical terms, we will need to find this point of intersection through our equations, and we should equalize 20 plus 2q to 20 plus q, because they are our equations, our functions, and we will see that q is equal to 0 in this case, and this again proves that we will not produce anything. And our part B is about the case where our average variable cost is at its minimum. So average variable cost is equal to 20 plus q, which we received in the previous step. And if we take the derivative of our average variable cost from Q, we will receive 1. And so when we need to find the minimum of our average variable cost, so we will need to look again at our graph and see that the minimum of average variable cost will be equal to 20. So now let's continue with the same task. And in the second part of it, we will need to find our quantity supplied profit in case of our market price will be equal to 30. But firstly, let's obtain our equation of supply. And for this purpose, we can use the equation of the marginal cost, because in this interval it will be the same. So we will use the function of marginal cost, and instead of marginal cost we can write P, and then write our equation for marginal cost, and it will be 20 plus 2Q. Q is equal to minus 10 plus 1/2 of P, so we take the inverse function. So it is quantity supplied. So to find quantity supplied, when the price is equal to 30, we'll need to put it in this equation. And the quantity will be equal to 5. We can also see it from the graph. When the price is equal to 30, quantity is equal to 5. And speaking about profit, we can find it using two formulas. The first formula is total revenue minus total cost. So total revenue is equal to price multiplied by quantity. So in our case, our price is equal to 30 and quantity is equal to 5. And we also will need to compute our total cost. So minus total cost. According to our function, total cost is equal to 100 plus 20Q plus Q squared. So in case of our total cost is equal, our quantity is equal to 5, our total cost will be plus 25, and it will be 225. So in this case, we have 150 minus 225, and we see that we have a negative profit minus 75. And there is also a second method how to find profit. It is using formula price minus average cost multiplied by quantity. So how to find average cost? Well, we need to divide our total cost by Q, and we will receive 100 plus 20Q plus Q squared divided by Q. 100 divided by Q plus 20 plus Q, and if we compute our average cost, considering that our Q is equal to 5, we will need to put 5 instead of Q. 20 plus 20 plus 5, 45. So our profit using the second method will be equal to 30 minus 45 multiplied by 5, 15 minus 15 multiplied by 5, minus 75, the same answer as in the previous case. Yes, speaking about quantity supply, I would like to mention that this equation, sorry, not this one is relevant only to the one part of the quantity supplied. So the full equation will look like, here we will write this part because it is the second part which we actually used for our solution. Here the price should be more than 20, and in the first row we will write 0 because we will not produce anything if the price is less than 20. So actually you can see it from the graph that where the price is equal to from 0 to 20, we don't produce anything, and when it is more than 20, we produce some amount of units. And speaking about the signs, I mean this and this, for this particular case, it's not very important. I mean that we can write like this, and then we will have to use non-strict inequality in the second case, or we can use non-strict inequality here and strict inequality here. Because if we put 20 here, we will get 0, or if we put 20 here, we will get also 0, so it doesn't matter. I mean that the main rule is to include the point only in one inequality, so this means if 20 is included into the second equation, it should not be included in the first one. So that's it. So now we will work again with the same functions, same equations, but in this case we will need to determine which market price we will need to have that we will get non-zero profit. So speaking about this case, when the profit is zero, this means that our price is equal to average cost. So in this case we'll receive profit which is equal to 0. In our case, marginal cost is equal to average cost. So we need to equalize them, because if you look at the graph, here is marginal cost, here is average cost, and we are looking for this intersection. This point gives us profit is equal to 0. So we equalize our marginal cost and average cost. So just using our equations, we write 20 plus 2q is equal to 100 divided by q plus 20 plus q. We can multiply our equation by q, and we will receive 20q plus 2q squared is equal to 100 plus 20q plus q squared. So after computations, we will receive that q squared is equal to 100 and q is equal to 10. So as you know, our supply equation on the part where price is more than 20, it was equal to marginal cost. So we can write price is equal to marginal cost. And let's compute. So marginal cost has an equation 20 plus 2q. So I'll repeat it here, 20 plus 2q. And when our quantity is equal to 10, our price or marginal cost will be equal to 40. So again, returning back to the graph, this is our point where our profit is equal to 0. So if we want to receive the profit more than 0, our price should be higher than this. And this price in our case was 40. So to get non-zero profit, we need to take the price which is equal to, which is more than 40. And the next part is to find a minimum of average cost. So average cost is equal to 100 divided by Q plus 20 plus Q. So if we take the derivative of average cost, it is equal to minus 100 divided by Q squared plus 1, and we need to equalize it to 0. And this means that quantity should be equal to 10 to make this equation be equal to 0. And now let's take the second derivative from Q to check whether it's indeed the minimum point of average cost. So we take the second derivative, and it will be 200 divided by Q in the third power, and we can clearly see that it is positive because 200 is positive, Q is also positive, and this means that it is indeed minimum of AC. In this exercise, we have our function about Q and labor. We are given the price and the price for labor, which is 40, and we need to compute the change, the difference between marginal cost and average cost. So first of all, let's express L from our first equation. So L in the power of 1/2 is equal to Q divided by 20. I just rewrite our equation, and L is equal to Q squared divided by 400. And we know that our total cost function is dependent on Q and is equal to price of labor multiplied by labor. Our price for labor is given, it is 40, and our labor, we have just found it, so we write Q squared divided by 400, and it will be equal to 0.1 Q squared. Our marginal cost will be equal to the derivative of our total cost. So in our case, it will be 0.1 multiplied by 2 multiplied by Q in the power of 1. So it will be 0.2 Q. And the difference between marginal cost and average cost will be equal to 0.2 Q minus 0.1 Q, which is 0.1 Q, and we remember that it is the case of pure competition. This means that the price is given pure because of pure competition. And price is equal to marginal cost. It is equal to, so our price is given, it is 20, and our marginal cost as we compute it is equal to 0.2q. This means that the q is equal to 100. So the difference of marginal cost and change in the difference of marginal cost and average cost will be equal to 0.1 q, and 0.1 multiplied by 100 is equal to 10. Our next exercise is again about total cost, but in this case there are several firms in the market, and we are given short-run total cost function and also the function of demand in the market. So we know that profit is 0. We need to find the price and the number of firms. So as the profit is equal to 0, we assume that price is equal to average cost, because the profit is 0, and then the price is equal to marginal cost, because we consider this case as a pure competition because there are several firms, and quantity supplied in the market will be number of firms multiplied by our quantity supplied function. As I said, price is equal to average cost and to marginal cost. This means our marginal cost is equal to average cost, and it is AC minimum. Let's find our marginal cost. It is the derivative from our total cost. So the derivative from 400 is 0. Derivative from this part is 5. The marginal cost is 5, plus we take the power from q, and the q will remain in the first power. And our average cost is equal to 400 plus 5q plus q squared divided by q. So it is 400 divided by q plus 5 plus q. And we need to equalize these equations. So 5 plus 2q is equal to 400 divided by q plus 5 plus q. We will multiply our expression by q to get rid of some denominators. So 5q plus 2q squared is equal to 400 plus 5q plus q squared. After computations, we will receive that q squared is equal to 400 and Q is equal to 20. And this quantity is about 1 firm, because we took the total cost function of the 1 firm. So that is why we receive the quantity of only 1 firm. Actually, there is the second method, and it is not about equalizing, it is about finding AC minimum. And we need to find the first derivative of AC. It will be equal to minus 400 divided by Q squared plus 1. Then we equalize it to 0, and the quantity is equal to 20. And we check whether the second derivative is positive. So it is the second derivative from AC, and it is positive, so this means that we found AC minimum. So we received the same quantity just by other method. So our next step, price is equal to marginal cost. Marginal cost, we know the equation of marginal cost, 5 plus 2Q. So we take our quantity and put it here, plus 5 plus 40, 45. This means that our price is equal to 45. And let's see what will be quantity demanded by market if the price is equal to 45. So we use our quantity demanded market and put the price of 45 into it. It will be 240. And now we need to equalize our demand for market and our supply for market. It will be 240. So, and now we know how many units does one firm produce. So quantity supplied market is equal to N multiplied by quantity produced by one firm. So 240 is equal to N multiplied by quantity produced by one firm. And from this we receive that the number of firms is equal to 12.